In this video, we will look at a few examples to practice working with the binomial probability density function button on our calculator. Example A says a local food chain has determined that 40% of the people who shop in the store use an incentive card, such as air miles. If 10 people walk into the store, what is the probability that half of them will be using an incentive card? So this is a binomial situation because for every person coming in, they will either use the incentive card, that would be a success, or not use the incentive card, which would be the failure. There's two options, use the card or don't use the card. And we know that 40% of people use the card. So the probability of success is 40% or 0.4. And we know that we basically have 10 trials because 10 people are walking into the store. And we want to know the probability that half of them, which would be 5 people, will be using the incentive card. So we have the number of trials is 10. The probability is 40% or 0.4. And our x value, which is the number of successes we're wondering about the probability for, is 5. So we want to know, in this case, the probability that x equals 5. And that's what we're trying to figure out. So in our calculator, we go into the distribution menu and scroll down until we get to binomial probability density function, Binomcdf. And once we've selected it, we can enter in what we want. In this case, we have 10 trials. Our probability is 0.4. And our x value is 5. Once we've entered that in, we can click paste and then enter again. And we get our probability is 0.2007. Or you could just round it to 0.20. So that's about a 20% chance that exactly 5 people will use the incentive card. All right, let's go to example B. Karen and Danny want to have 5 children after they get married. What is the probability that they will have exactly 3 girls? Okay, so this is also a binomial situation because you will either have a girl or you won't have a girl. So a girl in this case is what we would consider success. So the number of trials is 5 because they're going to have 5 children. We should assume that the probability of success, or the probability of having a girl, is 0.5, that they have just as much of a chance of having a girl as a boy. So probability equals 0.5. And we're wondering, what's the probability that the number of successes will be exactly 3? Now we can use our calculator to help us out. So again, go into your distribution menu and scroll down. Once you get into the Binomcdf menu, we want to type in 5 for the number of trials, 0.5 for the probability, and 3 for the number of successes. Then we can paste and click enter. And we get our answer is 0.3125, which is about 31% chance. So there's a 31% chance that they will have exactly 3 girls in their 5 children. All right. Example C, a fair coin is tossed 50 times. What is the probability that you will get heads in 30 of these tosses? So again, this is a binomial situation because you will get heads or you won't get heads. Only 2 possible outcomes in each trial. The number of trials is 50 because we're tossing the coin 50 times. The probability in each case is 0.5 that we will get heads, and getting heads in this case is our success. And we're wondering what's the probability that the number of heads or the number of successes is 30. So again, we can go into our calculator to help us quickly calculate this and enter in the data, 50 trials, 0.5 probability, and we're wondering about 30 successes. Paste and enter. And we get our answer is 0.0419. So that's about 4% chance, 4.2% chance that we'll get exactly 30 heads in our 50 coin tosses.